Video coverage of the 27th JCT Traffic Signal Symposium is brought to you by Highways News, thanks to our sponsors AGD Intelligent Traffic Systems, Clearview Intelligence, PTV Group, Message Maker Displays, Smart Video and Sensing, SRL and TRL.
Thank you very much. That's quite loud, isn't it? I better talk quieter. So I'll start with an apology. You're about to find out why they don't let me out of the office. This is my first time at JCT. So as the title goes, it tells you absolutely nothing. But what I'm going to tell you about is two things. First thing is a problem. Second thing is a solution. Now, TWM and TechSpan VMSL, you may not be aware, I was a technical director for VMSL, or VMS Tech as it was. TWM bought elements of the VMSL business, and we joined the pilot group in TWM in October last year. Now, does anyone remember a film called Flight of the Navigator? Yes, yes. Well, guess what? I found a new toy, a new tool, and we're going to do exactly that. So first and foremost, I'm going to take you to Gateshead, where we're based, as we zoom in to the centre of VMS technology. Now, beyond there, I'm going to talk to you about some bridges. Now, I would be remiss if I didn't talk about our own Tyne Bridge, built in 1928, 389 metres long, connecting Gateshead with Newcastle. And as we do the Flight of the Navigator thing, we're going to zoom up the East Coast, and I'm going to have a look at some bridges on the way, because predominantly I'm going to be talking about bridges. And here we come into the Forth Road bridges, the Queensferry Crossing and Forth Road Bridge, built in 1964 and 2017 respectively. Now, I'm going to scoot over Fife, because that's the best thing and only thing you can do with the Kingdom of Fife. And we're going to land at the A92, which is the main trunk road into Dundee, connecting the Kingdom of Fife to Scotland's Sunshine City. And we're going to talk about the Tay Road Bridge. Now, they have a problem. It's not that they connect to Fife. Now, we can see the Tay Road Bridge control room there, and I'm going to talk to you about the project that we're currently planning for and will be implementing in the coming year. Now, it's a two-year project, so hopefully next year I can come along and tell you how we got on. Right, the problem. They're going to be resurfacing it. First time it's been resurfaced since 1966. I'm sure you all know what happened in 1966. We always hear about it anyway. So, they're going to be resurfacing the Tay Road Bridge. During that time, they'll be running a contraflow. Now, the Tay Road Bridge is slightly different from regular bridges because it consists of two dual carriageways with a central walkway. Each dual carriageway is 6.7 metres wide, central walkway of 3 metres, and it runs for 2.25 kilometres. Now, the problem is they want a flexible solution. They want to be able to do this contraflow, but also they want a solution that goes beyond the contraflow and helps them out. So the highest recorded wind speed on the Tay Road Bridge, because it's this 2.25 kilometre bridge that goes across an estuary, is 121 miles an hour. Now, imagine a situation where you have 121 mile an hour winds, you might want to reduce the speed limit or even shut the road. In that situation, they send a guy out to the side of the road and he flips a plate sign, or he sticks on a VMS that's 25 years old. Not ideal. So what they want is something that will deal with the resurfacing issues for them, but will also provide a full control system beyond there that allows them the flexibility to alter road speeds, to communicate live information to the drivers, but also give them anything else that they particularly want, be that TSRG compliant information or information on events happening in and around Dundee. So, the concept was we need a sign. Hardly surprising that a sign manufacturer would say we need a sign. Now we came up with this concept that it should be fairly small. It should have speed detection built in. It should have a flexible display, obviously 12966 compliance, TSRGD compliant in terms of pictograms and aspects, but also should be modern and flexible. As Shailish pointed out, UTMC is very old. But also, it should have an open system architecture. So it should be able to communicate with everything. It should be able to integrate everything. So we thought, okay, if we're doing that, maybe we should think about communications and how it communicates. So we went through a whole heap of options. The options being, well, should it have a cloud-based system, a physical server? Should it be able to be standalone? Or should it have a roadside controller with a cluster of signs connected to it? And the answer was, actually, if we were doing a flexible system, it needed to be everything. So that's what we did. So the Tay Road Bridge consists of 19 of these small matrix signs, plus further refurbishment of TechSpan and VMS signage. We've calculated that by refurbishing the VMS and TechSpan signage on the bridge, the customer, the Tay Road Bridge Joint Board, will actually save 6 tonnes in CO2 when compared with buying a new sign, or replacing those with new signs, should I say. So, we wanted a system that not only managed contraflow, but also provided them useful data. Data such as speed, the average speed of the cars going over. How many cars went over in the first place? All this information is manually collated. So an automatic system that didn't require any, loops or anything as old-fashioned as that would be quite interesting. But similarly, we thought, well, actually, they want adaptive speed. They want to be able to change the road speed depending on any adverse weather conditions. Furthermore, they would want to change driver speed behaviour. I'm sure we're all familiar with the yellow average speed cameras, the specs cameras. They would want daily, monthly and weekly figures on what was happening on that bridge to allow them to make educated decisions on enforcement, on any number of things actually. But it should also be flexible. So, on the Tay Road Bridge next year, we will be deploying this new system, these 19 new signs. Now, as I'm sure John will confirm, he saw me handling one of these signs out at the back of the car. They're not big, heavy things. I couldn't have done that with a VMS MS4, but I certainly could do it with a mini matrix. So that's what we did. So we're deploying these small signs along the full length of the bridge. And how it will work is northbound carriageway is closed, southbound carriageway is open, and we have all 19 signs deployed from that central walkway and onto the contraflow. When the southbound carriageway closes, those signs are simply moved from one side of the walkway to the other side. No specialist lifting requirements here, because if I can do it, anybody can do it. And then, finally, in full operation, all the signs deployed on either side of the carriageway, providing real-time information to the drivers. So basically, the idea was, let's make a small, flexible, but intelligent sign. Any questions?
Do we have any questions? What sort of issues do you have with the weather? What sort of issues do you have with the weather? Because my experience of actually going up back and forth and places like that is it can be a little bit unpredictable.
So real weather, as I like to
That's the
call it.
one, yeah.
So yes, as I said, 121 miles an hour is the maximum wind speed recorded. Obviously, we have aspects of driving rain, high, well, snow, you name it. So basically, the way the phasing of the plan is projected to work is during the spring and summer months, 6 months on one carriageway, then 6 months off to allow the weather to do what it does, and then another 6 months back in spring through summer doing the alternative carriageway. So really a 2-year programme of works. So it should be quite an interesting one. And plus, we won't know if any of this works until 2 years' time.
Okay. Anyone else got a question? Oh, got one over there.
Thank you. Stewart, the bad news is this isn't a question about the signs, it's about the control strategy.
Oh, yeah.
So, from what you were showing, a 50 limit and a 30 limit, and possibly lower.
Closed. Yeah.
It's very easy for the traffic when you're going from a low speed limit to a higher one because they're not going to be breaking the speed limit at the time. But if you're coming onto that bridge at 50 and you start to drop the speed limit, what sort of allowance or buffer zone or sequencing of that limit might you be putting in place? Is it a ripple, or do you just say, we'll give everyone 5 minutes to clear before we try and enforce?
It's not an enforcement system, it's purely advisory. But the joy of it is you have a roundabout at the south side, so vehicles have to come to a stop. And the side, the Dundee side, the north side, is traffic light controlled. So you've got full control over it.
You've got some gating effectively.
Yes.
Okay, thank you.
Anyone else got questions? No? Okay then, well, thank you very much.
Thank you.